All right, we're getting close to the end, which is good. I'm getting tired. You're not intended to have to do like all of them all in the same shot. So like, this isn't the thing that I intend you to be experiencing, but I guess I got to do it. Let's prove something involving topology. Let's let U be a subset of the real line. Let's let X be interior to U. We will show X is a limit point of U. All right. And we'll start writing things in the proof down soon, but let's think about what we want to show. So we want to show X is a limit point. So what does that mean? That means we want to show that's okay, want to show, for every delta bigger than 0. So for every positive number, I don't care if you call it delta or epsilon, or something else, there is some y in U is the name of the set, with 0 less than absolute value x minus y less than delta. And the 0 is less than is just capturing that x is not equal to y. So I need something other than x itself, which is really close to x. So how am I going to do that? Let's write down the assumption. We got to assume x is interior. So that means I know something. I know there exists a delta. I'm not going to call it delta because delta already has a job. So that means there is some, let's call it delta 0, such that x minus delta 0 to x plus delta 0 is contained in U. So let's draw a picture of that. There's this x. There's x minus delta. There's x plus delta. Everything in between, all of this is a subset of U. Oh, delta 0. And now let's think about the thing we want to show. So I now need to pick a delta 0. And I need to show that there's something in this pink interval other than x itself, which is in U. Ooh, wait, but everything in the shaded in interval. How about let's take the midpoint between x and x plus delta. So I guess that's x plus delta over 2. Oh, that'll be in there. Except I guess delta might be really big. In that case, sorry, there's x. Well, the midpoint might still be beyond, but in that case, I think I could just use the midpoint between those two. Oh, cool. I think that'll do. Let's write the proof. So let's see. Let's start with the assumption. Since x is interior to U, there is some delta 0 such that x minus delta 0 to x plus delta 0 is a subset of U. All right, cool. Now, let's consider any delta bigger than 0. We must find a y in U with absolute value 0 less than absolute value x minus y is less than delta. And based on what happened over here, I think we want to use cases. Case 1. Let's assume delta is less than or equal to delta 0. In that case, let's see, we took the midpoint between x plus delta and x. So let's let y be, gosh, That's x plus half of delta. And now let's think about what I need. I need x to not be equal to y. Then, let's start with y is in u. I need y is in u, I need this inequality, I need that inequality. Oh, sorry, I was doing the out of focus thing. I need to remember to press that button every time. So let's start by explaining why y is in u. Well, why was y in u? Well, the little interval was a subset of the big interval. Big interval by assumption is a subset of u. Then, let's see, since absolute value x minus y, well, it's going to be equal to delta over 2, is less than or equal to delta, which is less than or equal to delta 0, it follows that, well, let's see, I need y to be in this range. So how do you do that? Well, I guess you take this inequality and you like solve it for y, but we've done that enough times that I don't think we need to do it in detail. It follows that x minus delta 0 is less than y is less than x plus delta 0. So y is in x minus delta 0 to x plus delta 0, which is a subset of u by assumption. Oh, not x, y is in there by assumption. All right, cool. So we have y is in u. Let's explain why y is not equal to x. Oh, well, that's like obvious. As delta over 2 is not equal to 0, y equals x plus delta over 2 is not equal to x. So 0 is less than absolute value x minus y. I need it to be less than delta. Finally, absolute value x minus y is equal to the absolute value of x minus x plus delta over 2. Oh, that's just delta over 2 is less than delta. Oh, neat. So we have found a y in u with 0 less than absolute value x minus y less than delta. Oh, neat. So we're done with this case. Case 2. Let's assume delta is bigger than delta 0. And let's go back over here and remember what we did. Well, instead of taking the endpoint between this endpoint and x, we took the endpoint of the thing that I knew was a subset of u and x and just used that. Let's use that. Let's let y be equal to x plus delta 0 over 2. All right, so I'll try to be quicker this time. Then absolute value of x minus y equals delta 0 over 2. That's less than delta 0. So y is in x minus delta 0 to x plus delta 0, which is a subset of u. So y is in u. We need y to not be equal to x. Oh, but it's x plus a bit. It's x plus a positive bit. So same thing. Since delta 0 is bigger than 0, y equals x plus delta 0 over 2 is not equal to x. So absolute value of x minus y is bigger than 0. Finally, absolute value of x minus y, I want it to be less than delta now. Well, it's not equal to delta 0 right now. Oh, but we're in the case that, less than delta, it's equal to delta 0 over 2. Well, I'm in the case right now that delta 0 is less than delta, so that's less than delta over 2. that's less than delta. So absolute value of x minus y is less than delta. Either way, for any delta bigger than 0, we have built a y in the set U with 0 less than absolute value x minus y less than delta. So x is a limit point of the set big U. That completes the proof. Neato. All right, just one left. We're going to do an epsilon delta proof.